Okay, here we are, 9-3, day 1. Okay, what we're going to look at today is a streamlined version of what we did yesterday, that integration by parts. So I just want to do a review problem, and then we want to streamline it so it goes a little bit quicker. In other words, get a shortcut for it. So let's just start out with one from yesterday. Let's say we had the integral of x squared times sine of x dx. Okay, so we have an x times an x. I can't integrate that unless I do it by parts. And so we define our u and our dv. And let's see, should I write down that formula for integration by parts? No, because it's in the pattern there. So remember, we let the u equal the x term unless we've got a natural log, then the u would equal the natural log. But that's not the case. So we'll let u equal the x squared. We'll let the dv be that part. So there's x squared. The dv equals sine x dx. So now here I know in integration by parts I need to know what du equals, so I take the derivative on both sides. So du equals a 2x times dx. Here I'm going to integrate so that I can get back to, let's see what v equals. So the integral of 1 dv is v. Integral here, what has sine as its derivative, would be a negative cosine. And then the integration by parts, the formula is the u times the v. And then we've got the integral of u dv. Okay, so integrating, was it minus the integral? It's minus the integral, isn't it? So I better look. Yes, it's minus the integral. Okay. So we will have a negative x squared cosine x minus this integral of negative 2x cosine x dx. Okay, looking to integrate this, I've got a product in here again, so I need to fix that. Before I get going though, I think I'm going to bring this negative out and make it positive. Now I'm going to do integration by parts with this integral here. So again, I'll let u equal the x part, which is 2x. The dv will equal the cosine x dx. Doing the derivative here, du equals 2 dx. Integrating here, this brings me to v equals sine x. Okay, so now multiply here minus the integral here. So carry that along, negative x squared cosine x plus u times v is 2x sine x. Then minus the integral of 2 sine x dx. Okay, so integrating, carry along. Here, what has sine as its derivative is a negative cosine, so I would have a minus a negative cosine, well, 2. That'll turn into plus 2 cosine x, and a plus c. Okay, that gets to be a little long when you have to do integration by parts multiple times. Well, we're going to take a look. And if you see what I've got here compared to what I had, the first part's not a problem. But then if I look at my next term, that was this 2x times this sine x here. And then I had the integral, obviously, across here. the way we can streamline this, so I'm going to redo the problem in the streamlined version. Instead of letting u equal x squared, I'm going to make two columns where I've got a u column and a dv column. So what's going to happen is we're just going to leave out a lot of the unnecessary stuff, knowing that I have to take the derivative of this term. So I'm going to start with the x squared. And over here, I'm going to let the dv equal sine x. I'm not going to bother with the dx here because I know it's on the dv term every single time. So we're just going to, and I'm not going to bother with setting dv equal. I know that this is the column. So it's going to eliminate some of the unnecessary stuff. I know I do derivative on the u term all the time. So derivative, the next derivative would be 2x. The next derivative would be 2. And the next derivative would be 0. I'm going to stop when I get to 0 if that keeps decreasing like this one did. So stop when you get to 0. What I want to do over here now is integrate. I know I'm integrating on this one. So I'm not going to bother with the integral symbol anymore. So what has sine as its derivative is negative cosine x. Now I'm going to integrate again because I got to have just as many over here as I do over here. So what has negative cosine as its derivative is negative sine. And then what has negative sine as its derivative is cosine. Now the pattern now becomes, what we're going to do is multiply along the diagonals here. Those are going to get multiplied. And we're going to be integrating across the bottom horizontal row. And what happens is the plus and minus alternate. There's going to be a positive 1 multiplier, negative 1 multiplier, positive 1 multiplier, negative multiplier. So it always starts out positive and then alternates all the way to the last one. So think of this as a positive 1 multiplier, so it's just these two multiplied together. So I will have a negative x squared cosine x. The next one, I've got a negative 1 multiplier times the 2x times the negative sine. That's going to turn into a plus 2x sine x. Okay, we're looking good. Negative x squared cosine x, negative x squared cosine x, plus 2x sine x, plus. My third one is a positive 1 multiplier, 2 times cosine, so plus 2 cosine x. This, when I multiply, I'm going to get 0. The integral of 0 is still just 0. So there's nothing there, and all I need now is my plus c. So this is called rapid repeated integration by parts. So for rapid repeated integration by parts. What you're going to do is use two columns. Choose your u and dv terms. You do derivative down the u column. So take derivative of the u column until 0 appears. Or something else, or, and the next one, you have to take the integral of the v column, dv column, because sometimes this doesn't simplify all the way down. We had one yesterday. So if this is not going to come down to 0, then the other option is to make your original dv reappear. So take the integral of the dv column until the original dv reappears. And we'll do one of these in a minute. And whatever one it is, if it's the 0 one, you just have to integrate as many times. If it's the do this until it reappears, you do this one as many times. And then, third step. The pattern is to multiply down the diagonals alternating a 1 and -1 multiplier. So with the positive one you start with, then it goes to the negative one, you just alternate all the way down. And then, if necessary, you integrate across the bottom row. Integrate across bottom row, if necessary. So in other words, if it's not 0, you are going to have to integrate what's there. Okay, so let's do a couple more so things come up. Start easy, just like the one we just had. Let's go x cubed sine x dx. So define your u and your dv. Remember, u is always the x term unless we've got a natural log in here. So I'm going to let u equal the x cubed. I'm going to let dv equal the sine x. And we're just not going to bother with the extra stuff we don't need. I know I do derivative here. This one is one that's going to get down to 0. So 3x squared, 6x, 6, 0. Here I'm going to integrate. This will be negative cosine. Next one will be, think about it, negative sine. Next, what has negative sine as its derivative is cosine. And then what has cosine as its derivative is sine. So you start at the top and you make your diagonal. So it's the first u that gets multiplied by the second dv. That, 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 and my horizontal that I integrate is going to be a 0, so I won't have to. Positive multiplier, -1, +1, -1, +1. Okay? So, see if I can squeeze it in over here. I'll have a negative x cubed cosine x. Next one will be a positive 3x squared sine x. A positive 6x cosine x. And then integral of 0 is 0 plus c. Okay, not too bad. Once it's streamlined here, number 3. Let's go with 2x to the 4th e to the negative x dx. Okay, u dv. Okay, I'll let u equal the x term, 2x to the 4th e to the negative x. Okay, derivative. This will be 8x cubed, 24 x squared, 48 x, 48